A final approach goes horribly wrong.
Just wondering how it's gonna end.
The dramatic rescue in San Francisco is caught on camera.
They use the terms mass casualty event.
The search for a cause
Bingo.
divides air safety experts.
The worst mode possible.
I disagree.
Was it the pilots, the plane, or something else that doomed Asiana Flight 214?
The hard part is to say, which one is the straw that broke the camel's back?
Mayday, mayday.
Ladies and gentlemen, this is your captain speaking. We hope you had a pleasant flight. We'll be on the ground in about 30 minutes. Enjoy your stay in San Francisco and hope to see you again soon.
Asiana Flight 214 is nearing the end of an overnight flight from Seoul, Korea to San Francisco. Ben Levy is a frequent flyer, returning home.
And I fly pretty often for business or visiting my family. I'm originally from France, and so, I fly long distance a lot. I fly in and out of SF a lot. So I know the airport very well.
Many of the other 291 passengers are Chinese, including a group of teenagers on their way to summer camp in the United States.
I think they were all pretty excited about the trip. I think they were all having a good time and excited to be in that plane and going to the US.
Is that the Golden Gate?
Captain Lee Kong-Cook takes in the sights as he guides the plane towards the airport.
Golden Gate's over there. That bridge goes to Oakland.
Ah, okay.
Lee Chung-min, also a captain, is serving as first officer today.
Yeah, I remember being a just gorgeous day, as good as it can be. No wind, beautiful sunny day, not a single cloud in the sky.
The arrival into San Francisco is a very scenic approach from the Sierra Mountains all the way into the San Francisco Bay Area. It's a very pretty arrival.
Runway in sight.
Asiana 214 heavy, turn left 310 degrees. Cleared visual approach.
Controllers clear the crew for their final turn to the runway.
It is a busy piece of airspace. You do have to listen on the frequency, and you do have to anticipate what the controller is going to give you. In addition, experience really counts flying into San Francisco.
Cleared visual approach, Asiana 214. Okay, gear down, sir.
Gear down.
The way we put on the brakes in an airplane is by putting our trailing edge flaps down, our leading edge devices down, and even the gear, that's our brake.
They then enter an altitude to climb to in case of a missed approach.
Missed approach, 3,000 feet.
In the cabin, the flight attendants prepare passengers for landing.
Asiana 214 heavy, runway 28 left, cleared to land.
Landing checklist complete. Clear to land. On glide path.
The pilots check a set of lights beside the runway that can help guide them to a safe landing.
Check.
The plane is less than a minute from the runway when Ben Levy realizes something is wrong.
I remember noticing that there's a small pier that extends out of the runway, and I'm like, wow, we're very low. And I dismissed the thought thinking, well, what can go wrong? There's all the technology on board to make sure that those guys don't mess up.
In the cockpit,
Speed!
a crisis hits.
I got control. Oh, God! Go around!
In that fraction of a second, I feel the thrust of the engine re-engaging full throttle.
The captain pulls up the nose and tries to climb. But it may be too late.
Hang on. Looks like we're not gonna make the runway.
At that point, I'm thinking we're gonna hit the water. Impact was very violent. Just wondering how it's gonna end, how it's gonna stop, and when it's gonna stop. So the plane comes to a rest. And nothing moves. And all you hear is moaning from people that are hurt and injured.
Here. Here. You press hard and you stop the bleeding.
In the cockpit, the pilots have survived, but they have no idea how badly damaged their aircraft is. The brutal impact has torn the tail off the body of the plane.
Control, come in. It's Asiana 214.
Initiating evacuation checklist.
We need help out here.
Asiana 214 Heavy, emergency vehicles are responding.
An engine is burning. If fire spreads to the fuel tanks, the plane could explode. Passengers need to find a way out, fast.
Let's see if we can open this door.
I remember just going for that big lever on the right-hand side of this airplane and just opening this door. And was shocked at how easy it was.
But getting down to the ground will not be easy.
I'm expecting at that point to see a slide open. Right, the whole like, hey, you open the door, the slide is gonna open, and there's no slide.
Whoa. Okay. Help each other. Come on.
Luckily, some crumpled pieces of the fuselage have formed a makeshift set of stairs. Ben Levy stays by the door to help the other passengers climb down.
Come on.
You know, in this whole disaster, the fact that the fuselage actually had crumbled on itself almost provided like a step that became probably critical for people to be able to exit that plane.
Oh my God, that's scary.
Eyewitness video captures the dramatic scene as hundreds of people flee the cabin from only a few exits. The 777 has 8 exits. Each is equipped with an emergency escape slide. The slides are supposed to inflate automatically, but only 2 have deployed properly.
Someone, please help me.
What's worse, 2 of the malfunctioning slides have inflated inside the plane. A flight attendant is trapped.
I can't move. If you pull, I can try. No, get something sharp.
Expert. He understands the desperation the crew is facing.
They were worried about her suffocating, and so it was a very strong sense of urgency to try and get her out. Plus, there was a fire outside the fuselage as well. So, yeah, it was a pretty serious situation.
At San Francisco International Airport, runway 28L is a disaster zone. Fire crews battle to keep flames from consuming the fuselage of Asiana Flight 214.
Come on. Get out.
Inside the burning plane, a flight attendant is still trapped.
The slides are pretty tough. You need a sharp, strong object to be able to puncture the slide, and crash X do the trick.
With rescuers now on board to help the injured, Ben Levy finally heads to safety.
I think in my head, I was like, I'm alive, it's incredible.
He's soon sharing his harrowing story with the media.
In your head, everything goes in slow motion. You just don't believe it's happening. You don't know if you're going to be dead at the end of this slow motion or not.
And the entire trauma team has come together as they would in a trauma, although this is very large, multi-casualty incident.
Nearly 50 people are seriously injured. 6 were thrown out the back of the plane when the tail broke off. 2 of them are dead, including a young teenager run over by an emergency vehicle.
The fire truck did go over the victim, that's a fact. Now, what caused the death, whether the victim was deceased before or as a result, that is what we're trying to figure out.
Like thousands of others, investigators at the National Transportation Safety Board in Washington are riveted by the pictures.
They used the terms mass casualty event. We really didn't know what was going on at the time. The first things I heard was an airplane cartwheeled, mass casualties, and we knew it was a 777, so it was going to be a very significant event.
Senior investigator Bill English will lead the high-profile investigation.
Everyone's on standby, as of right now.
So the 777 had been in service for about 20 years at the time of this accident, and this was the first fatal accident of a 777 in that entire time. We knew we were going to be launching a very large team, so we pulled out all the stops.
By the next morning, there's a full team of investigators on site. Their first impression is that the media reports must be wrong.
I'd heard the phrase, the airplane cartwheeled. And the first photos that I saw showed the airplane right side up, wings still attached, still looking pretty much like an airplane sitting next to the runway. So we thought that couldn't be true.
When a plane cartwheels on touchdown, the result is usually a catastrophic breakup that leaves a long trail of debris. That's what happened in 1989 in Sioux City, Iowa, where a DC-10 cartwheeled off the runway, killing 111 people. The wreckage from Asiana 214 looks nothing like Sioux City. English can hardly believe the 777 cartwheeled until he spots some telltale evidence.
We noticed the marks on the runway, scrape marks and everything. Looked strange. It looked like the airplane twisted and turned around. We thought, did the airplane actually turn around? And then we saw the video.
Airport surveillance cameras leave no doubt about Flight 214's violent trajectory.
The surveillance video did show the airplane literally pirouetting, lifting a good 30 degrees into the air, spinning almost a full circle around before coming to rest.
It's just a miracle in so many ways. The fact that this plane stayed in one piece, the fact that the wing didn't break apart. I mean, if we had landed back any other way, it could have been terrible.
Investigators must now determine why the 777 crashed short of the runway. But they also face important questions about the evacuation and rescue.
How did you end up out there?
Investigator Jason Feddock will try to figure out what happened to the passengers after the impact.
Can you remember where you were sitting?
People who were actually involved in the accident gave us a wealth of information that we couldn't otherwise learn about what happened inside the cabin.
Was she wearing her seatbelt?
In this case, we talked to the seatmates of one of the ejected passengers who explained that she was not wearing her seatbelt at the time of the accident.
This investigation was almost 2 investigations in one. We broke it up into the part that got us to the seawall. How did this airplane impact those rocks and come to this accident? After that was a whole other story to be told.
The complex investigation puts the entire team under enormous pressure. There could be clues inside the ruined cockpit, but toxic fumes and scorched debris make it too dangerous to enter without protective gear.
Okay, here we go.
For NTSB investigator Roger Cox, the hunt for evidence is worth the risk.
It was a tricky accident site. We had to be properly garbed up to make sure that we weren't affected too much by the dangerous wreckage that was there. If you get out there right away, before anybody's had time to move anything around, you can actually reconstruct what went on.
Cox gathers the pilot's charts and personal effects hoping to find clues about what they were doing in the final stages of the flight.
That's everything I could find.
We removed every single document and then make sure that we photographed every single page of every single document in order to see if any of it was of value.
Many of the documents are in Korean. They'll need to be translated before they can be fully analyzed. The crash zone, on the other hand, immediately provides investigators with some important details.
Where it impacted on the rocks of the seawall pretty much tells us it was too low. It landed well short of where it should have.
The scenario reminds English of another very similar accident.
One of the things we initially thought about was a previous 777 accident that happened in London, England, where both engines rolled back and the crew didn't have any power at all on final approach.
The 777 has one of the best safety records of any plane in the sky. But in 2008, British Airways Flight 38 slammed to the ground short of the runway at Heathrow Airport after losing power in both engines. Investigators determined that ice in the fuel lines had caused dual engine failure. Is that what happened to Asiana 214? A close look at the engines tells Bill English the answer is no. He sees clear evidence that they were working normally.
There are certain signatures in the metal, in the blades of the engine, that show us that they were developing power and hadn't failed.
For now, English has no solid leads to explain why a plane that seemed about to land safely crashed just seconds from the runway.
We knew the weather was good, winds were calm, visibility was good. There was no distress call from the airplane that we'd heard of, so there was nothing really obvious as to why this would have occurred.
Runway crews assess the damage at San Francisco International Airport, while investigators search for a lead in the crash of Asiana 214. Air traffic controllers provide some answers.
They could see it on radar and, of course, visually see it from the tower.
Visibility was 10 miles, a few clouds, not an issue.
Controllers tell investigators that it was a normal day, except for the fact that some runway equipment was not in operation.
And that runway's glide slope was out of service.
Electronic equipment installed on runways can send signals to a plane's autopilot. The signals can help guide the plane down at a precise angle. But the main runway at the airport is under construction, and the equipment is switched off. It's a revealing discovery. A combination of high traffic and compact runways have earned San Francisco Airport a reputation for difficult landings. To manage the high traffic, controllers often ask pilots to come in fast and steep, leaving lower altitudes open for departing planes to climb out.
Very often we are given what we call the slam dunk approach, where we're high and we have to get down quickly, and it does create a little bit of a challenge.
All right, so there's San Francisco Airport. Palo Alto's down here, you know.
Roger Cox knows firsthand how challenging landing at San Francisco Airport can be.
I can say from my own personal experience flying there many, many times that it's very easy to get high and hot, and you have to really stay on top of the airplane.
Asiana 214 heavy, runway 28 left, cleared to land.
It all leads to some troubling questions. Were the Asiana pilots flying into danger? Did they face an extraordinary risk at an airport notorious for difficult landings?
So he'd be coming in from this direction, straight across the bay.
Roger Cox studies airport radar records. He wants to know if controllers assigned Asiana Flight 214 an approach that was too fast and steep to fly safely.
Cleared to land.
There were some complaints initially from the operator that this crew was being asked to do something was unreasonable. So we wanted to spend quite a bit of time looking at whether that was true.
Same instructions, same approach, No one else had a problem.
Airport records reveal controllers gave 2 other planes the same instructions just before Asiana touched down. Both landed safely.
You can't fault the controller.
And they managed to land 777s safely without any difficulty. So although it is a somewhat challenging environment, we found that nothing that ATC did really caused the accident.
It's another dead end. For now, what brought down Asiana 214 remains a mystery. Along with the cause of the accident, investigators are grappling with another troubling question. Escape slides are engineered to withstand the forces of aviation accidents. Why did so many fail during the crash of Flight 214?
Only 2 of them did what they were supposed to do.
6 of the 8 slides didn't deploy properly, potentially causing deadly delays in the evacuation.
The fire took some time to get into the cabin. That's a good thing. But had a fuel tank been punctured or some obstacle been in the way and we had a much more rapid fire, things could have been very different.
They'll have to search for answers without the help of the plane's flight data recorder. The recorder is located in the tail section and stopped recording when the tail smashed into the seawall. There's no information on what was happening at the moment the slides deployed.
Okay, let's see what these slides can take.
To get the data they need, Jason Feddock turns to a crash test facility more often used for testing cars.
This is unlike anything anyone had ever seen before, so we wanted to figure out how that happened.
He discovers that at low speeds, the slides perform well. But in high-speed impacts, like the one on board Flight 214, the inflation mechanism can fail quite easily.
We made a recommendation to the FAA to look at the data we produced from this accident and see if there were improvements that could be made to future slide design to help make that part more robust.
The violent force of the impact also accounts for the injuries suffered by the 6 people thrown from the plane, including the young teenager who was run over by a fire truck. Autopsy results confirm she died immediately after the crash impact. She was already dead by the time her body was run over.
One of the most important lessons here is to always keep your seatbelt fastened whenever possible on an aircraft. You never know when you're going to have unexpected turbulence or be in an accident.
Investigators hope Flight 214's flight recorders will help them answer the other urgent question. Why did Flight 214 slam into the seawall in the first place?
I don't think we're going to make the runway.
Modern flight recorders capture detailed information about virtually every system on board, including the complex automation that helps the pilots fly the plane.
We were able to see all the basic things, like airspeed, altitude, the configuration of the airplane. We were also able to see all the inputs that the crew made.
English carefully plots the data. Most of it looks completely normal. But then he spots something unexpected. A little more than a minute away from the runway, engine power suddenly drops to idle.
Right here.
The sudden change in power settings makes no sense. Normally, the last moments of flight are when pilots need more power, not less. They need extra thrust to overcome increased drag from the landing gear and wing flaps. The investigation has already determined that there was nothing wrong with the engines themselves.
We could see that the engines were making proper power all the way through the approach.
The question now, what was the crew doing to control engine power in the critical final moments of flight?
Speed!
So that brought us right back to how did the pilots operate the airplane? Why did they do what they did that got the airplane too low?
What really struck me was how could a couple of highly trained, experienced pilots simply fly an airplane into the ground short of the runway? That was the mystery.
The investigation into Asiana 214 now focuses squarely on the actions of the pilots.
You're down, sir?
Understanding every nuance of the cockpit voice recording becomes crucial.
The CVR is key.
Gear down.
You can tell what the flight crew are doing. You can tell what they're thinking sometimes because they're verbalizing it. You can tell how they're deciding, what to do next.
They listen as the pilots prepare for landing.
Missed approach 3,000 feet.
They combine what they hear with the FDR data that shows how the pilots were manipulating the controls.
It seems a little high.
As the crew nears the runway, the recording hints at the first sign of trouble.
I will descend more.
The plane isn't descending fast enough. The captain flying takes steps to fix the problem, but he doesn't explain his actions to his co-pilot.
No call-outs. How's anyone supposed to know what he's doing?
For investigator Bill Bramble, it's a troubling clue.
The pilot flying is supposed to actually select things with the autoflight system and call out what he's doing, and the pilot monitoring is supposed to verify that the change has actually occurred. In this case, we saw kind of a breakdown in that standard pattern of communication and coordination.
Flaps 20.
What the recording reveals next is stunning. Less than 90 seconds before impact, the captain makes an inexplicable blunder. He switches the autopilot to an incorrect setting, flight level change mode. That interrupts the landing and instructs the computer to climb to the go-around altitude of 3,000 feet.
He made an entry to the autopilot that, at first, actually made the airplane climb. Obviously, he didn't want to do that.
The autopilot mode switches here. Starts all the confusion.
To bring his plane back down, the captain immediately pulls the throttles back to idle, a move with major repercussions. But once again, he doesn't tell the other pilot what he's doing.
Not calling out one single action wouldn't necessarily be a fatal flaw, but in this particular case, it had a big influence on the conduct of the flight.
It's low.
Investigators now understand how the engines got to idle.
Yeah.
But why would an experienced captain make the mistake of leaving them there?
Oh, God. Go around.
And why did the crew not notice they were dangerously low until it was too late?
It's like they just sat there and watched it happen.
To find answers, Bramble and Cox prepare for a sensitive and difficult interview with the pilot who was flying the plane.
I'll try to help if I can.
We wanted to find out, how much of what happened did they understand? We wanted to find out when they became aware that something was amiss. And so the only way to do that was by asking them.
I was a bit nervous.
The captain explains he was worried about landing in San Francisco on a day when there was no electronic runway equipment to help guide him.
I thought that was very unusual coming from an experienced pilot because no one really needs an electronic glide slope on a clear day to be able to land an airplane. It's a fundamental skill that you have to learn from the time you're a private pilot.
Other pilots are making that landing. I thought I should be able to make it too.
He said everyone else was doing it, so I could not say I could not do it.
It seems a little high.
I will descend more.
I think he didn't want to show that he was not confident or that he was not prepared. But I think, why did he not ask the other guy for help? I think he just didn't want to admit the weakness.
It's low.
The captain tells investigators he doesn't understand why the plane didn't have enough power on landing.
I know I made some mistakes, but I was certain that the auto throttle would control the speed.
Like other modern jets, the 777 can automatically increase or decrease engine power through a system known as the auto throttle.
Similar to, but much more sophisticated than your cruise control.
He was confident the auto throttle was actually going to take care of speed for him. And in his prior experience, they had.
During his 777 flight training, The captain was taught about the autothrottle's special wake-up feature. If the plane's speed drops too low, the autothrottle engages and adds power, even if it's switched off.
Amazing.
Because he had seen this demonstration in the simulator, that the autothrottles would wake up even if the autothrottle was off. So he had this really high level of expectancy that the autothrottles would wake up, advance the thrust, and keep them safe.
Investigators consider a chilling possibility. Did a critical automated system on a Boeing 777 fail in flight? Is that what doomed Asiana 214?
So the auto throttle and autopilot both change modes here and then again here.
Investigators dig deeper into the flight data from Asiana 214. They search for any evidence of a failure or malfunction in the plane's automated flight systems.
I think the most important thing that we wanted to know was what autothrottle and autopilot modes were engaged during the last 2 or 3 minutes of the flight.
Missed approach 3,000 feet.
An undetected problem with the autopilot or autothrottle could easily have led the pilots to disaster. Tracing all the computerized functions is a mammoth task. English studies every input, every mode change. The exhaustive analysis leaves no doubt. None of Flight 214's automated systems failed in any way. But there is evidence of something else that could finally explain what went wrong.
It was pretty evident that we could see some strange things happening with automation inputs while that airplane was on short final.
The analysis reveals that the pilots of Asiana 214 punched in a bizarre sequence of inputs, a sequence that most pilots would never carry out. First, choosing an autopilot mode rarely used during descent, then pulling back on the thrust levers when that error put the plane into a climb.
Bingo. That does it.
The unusual combination of commands switches off the 777's built-in speed protection, leaving the engines at idle.
At that point, he disconnected the autopilot, so now up, down, left, and right was in his hands. He grabbed the throttles and reduced them, like taking his foot off the gas. By doing that, that sent the signal to the autothrottle system that he wanted control of the power as well. So at that point, in effect, the airplane was basically just gliding.
Investigators finally understand why the autothrottle did not re-engage and boost engine thrust on landing. But puzzling questions remain. Why was the captain so uncertain about autopilot functions? And why couldn't the crew react in time to save their plane?
22,000 hours between them. You'd think they'd notice the speed.
Translated from the original Korean, the cockpit documents go a long way to providing some answers.
It turned out one of the important things that we recovered was the pilot training record, which had detailed history of what he had accomplished right up to the time of the accident.
The documents reveal Flight 214 was a critical training flight for Captain Lee Kong-kook.
Is that the Golden Gate?
He was transferring to the Boeing 777 after flying the Airbus A320, an aircraft with a very different style of automation.
Golden Gate's over there. That bridge goes to Oakland.
It's a different philosophy of flying, and he had flown the Airbus for quite some time, so the transition may still have been an awkward moment.
It was a training flight.
The training records reveal the captain had been having trouble making the change.
The instructor was fairly critical. He indicated he felt that the captain who was in training wasn't sufficiently diligent and attentive to procedure.
That recent criticism may have been on Lee Kong-kook's mind as he headed for San Francisco.
He was a little bit stressed because it was a training flight and he was being monitored by this more senior pilot, and possibly because of this previous flight where he hadn't performed so well.
But why were the pilots so slow to recognize the danger?
question that was on everybody's mind and carried all the way through this investigation is what was going on in the pilots' heads.
Clear to land. Even though the landing system was out of service, there was another way for the pilots to know their plane was too low. The runway is equipped with special lights that change color to alert pilots if the approach angle is off.
The PAPI, Precision Approach Path Indicator, that also aid pilots in the proper vertical path. Those were operating and were operating properly at the time of the accident.
It's low.
The pilots were shown 4 red lights, meaning the plane is dangerously low.
We had a lot of data, and it pretty much showed us an airplane that was working exactly as it was designed. That wasn't difficult. Getting into the whys of why human beings do what they do or don't notice things is a lot more difficult, and explaining that can be the hardest task of all.
Especially troubling. Why did the more experienced commander wait until it was too late before taking control of the plane?
I've got control.
If he had intervened sooner, he would almost certainly have prevented the accident.
The airplane was perfectly flyable up until really the last minute. So at any point, there were a number of places where someone could intervene, someone could take over, someone could make a small change, and this would have come out very differently.
Yeah, we're just trying to get a sense of how much experience your guys would have flying by hand. Can you get me some numbers on that?
They learned that Asiana has strict policies, encouraging pilots to rely on their aircraft automation as much as possible. They rarely practice landing the plane by hand.
And we have to go to the company's procedures and training. And there is where I think we've put our finger on the issue.
Cleared visual approach.
Investigators are shocked to learn that this arrival in San Francisco was the first time the captain ever attempted to land a 777 with no help from the glide slope signal on the runway.
When it comes to visual landings, this guy's an absolute beginner.
The vast majority of the time, he had been flying instrument approaches into airports even when he was technically flying the visual approach.
10,000 hours, almost no hand flying.
It's a stunning discovery. Despite nearly 10,000 hours as an airline pilot, the captain has almost no experience flying his plane by hand.
This seems a little high.
You take away all the time that was on the autopilot, and if you look at all of the flight hours that they had,
I will descend more.
They may have actually only had a couple of hundred hours of hand flying the airplane, maybe even less, during the years that they had been flying. So they hadn't been honing their skills.
Investigators also learned that the commander, though an experienced pilot, had never before supervised a training flight like this one.
Slow.
His inexperience most likely led him to wait too long before taking over the controls.
Speed!
As a flight instructor, knowing that critical point, when to intervene, when a pilot or a student is going a little bit too far, is one of the hardest tasks to learn as an instructor. It takes experience, time, and a little bit of extra knowledge being ahead of the airplane yourself as the instructor to see these things starting to decay.
Investigators agree the Asiana crew made serious mistakes that caused the crash.
Bottom line, they let their speed drop.
But they don't agree on why the pilots made those mistakes.
I think those modes would confuse most pilots.
But it's their job not to be confused.
Bill Bramble believes technology is to blame.
The way that we design airplanes and the way that airplane flight decks are evolving are influencing the ability of flight crews to stay in the loop and understand what's going on.
But Roger Cox believes the fault lies squarely with the human pilots.
We say pilots use cues to figure out where are we. So I couldn't quite grasp why professional crew hadn't picked up on these obvious cues that were right in front of them.
The crash of Asiana 214 sparks a heated discussion among industry experts working to make aviation safer. It's an age-old debate of man versus machine.
What's more significant? Is it more significant that the pilots did not simply take manual control and fly this airplane to the runway or go around? Or is it more significant that they were in this environment of automation that some people think was too complex.
Well, they fluked into it, the worst mode possible.
The more complex automation becomes, the more difficult it can be for pilots to understand the entire system.
I am not confident that the majority of pilots, 777 pilots at the time, would have been able to predict the modes that the airplane would end up in.
There have been other deadly accidents in recent years that underscore Bill Bramble's concern about automation confusion. Turkish Airways Flight 1951 was carrying 128 passengers on approach to Amsterdam when a faulty altimeter sent incorrect data to the autopilot. Speed began to drop. Like the crew of Asiana 214, the Turkish Airways pilots failed to react, thinking the plane's automation would maintain a safe speed. Accidents like this are extremely rare.
It's low.
But researchers say that's part of the problem. Automation fails so rarely that when it does, pilots aren't able to react as quickly as they should.
To me, this accident shows the inevitable consequences of the evolution of the modern flight deck. The increased automation, which has improved reliability, efficiency, and safety in many ways, but has left us with some unintended consequences when something anomalous occurs.
But not everyone agrees that cockpit automation has gone too far.
Bottom line, it's the pilot's responsibility to fly that plane.
Having flown a lot of airliners for well over 30 years in my career, I always felt it was incumbent on me and other old pilots to fully and totally understand every aspect of the airplane, particularly the flight path control, the autopilot, and the auto flight system, so you understood what it was going to do.
In their final report on the crash of Asiana 214, investigators address both sides of the argument. They list pilot error as the probable cause, but they also cite the complexities of the automation system as a contributing factor. In an unusual move, the report includes statements from 4 members of the National Transportation Safety Board, each emphasizing their own personal views on the crash. The report calls for better training for pilots, including more time spent flying without the use of automation.
There's a great movement now in the industry towards going back to basics. We've talked a lot about over-reliance on automation, but airplanes still fly pretty much the same way they have for decades. And we want to get back to making sure that pilots are ahead of the airplane, aware of what's going on around them, and able to keep themselves in that loop of flying, whether the automation is doing it or not.
The report also urges more intuitive designs for aircraft automation and better alarms in the cockpit to warn pilots if their speed gets too low.
It's hardly ever that we have an accident that's really just one thing. The hard part is to say, which one is really that critical event? Which is the straw that broke the camel's back? If there is any such thing. Sometimes it takes all those little things to make the accident happen.